Can you hear me? Or should I speak in this one? Okay. So hello everybody, my name is Andrei Kish, and today I'm going to talk to you about moldable debugging. So I work at Think, and here, can you hear me? Or okay, it's a bit strange. Okay, so I work at Think, and here our goal is to make the insides of software systems explainable. And for that, we are building Glamorous Toolkit, some of you heard about. And in this context, we're going to try to show you how we approach debugging within Glamorous Toolkit. So my entire presentation is more or less a long demo. Can you tell me if you see this okay? Or maybe we can make it a bit bigger. But yeah, that's the best, I think, because I need still a few space. So first, let's start by looking at an actual debugger. So we start with the normal debugger that's present in GT. And here I have some code that uses a parser. So we're going to use a SMAC parser. So this is a parser framework available in Pharo. And we're going to debug parsing some Java code. We do it and we get the debugger. So this is just the standard debugger, and let's just do quickly some debugging operations. So I'm going to step into, step over, step into, maybe step over, step into, step over, step over. And we can stop here for a second. So what you can see on the left is an overview of the stack. In the middle, we get the expanded stack. So we can look at multiple expanded stack frames, not just one. And then we have the object inspector on the right. And if there is an object that we're interested in, maybe the keywords, we can dive in by double-clicking, and then we get the object, and we can continue navigating if this is what we want to. But now this debugger is generic. It can be used for any application ever written in GT. It works. But here we are debugging a parser. And now I'm going to step into and start parsing. And within GT, we have several domain-specific debuggers for which we check if we can activate them or not after every operation. So the moment I'm going to do step into, one of those debuggers is going to become active. So I enter the parsing, and now at the top, I have GT and SMAC. So this is a debugger that's specifically designed for SMAC that became active because at this point, I am into a parser. I can switch to it, and I get a totally different interface. So this shows me the stream, this is the parsing stack, this is some information. I have some actions like maybe step to next token. So now it parsed public, it parsed class, it parsed person, and I can see a bit the look ahead in this parser. This is a look ahead. I can also go at a certain point in the input and say, please step to this part. And now the parsing reached here, and I can look at the look ahead and see, okay, it parsed this, and if something is interesting, for example, method header, I can again dive into it. I can double click, and then I'm into this object, and I can continue to explore it. And at every step, if I don't want to use this debugger, I can switch and go back to the generic one. I don't have to use it if I don't want to. So let's move to another example. Like this, you can hear me, or is still no? Okay. So let's try another example. So before you saw Gemstone. So from GT, we can connect to Gemstone. And what I'm going to do here is execute some code. So we have some data here. It's more or less the list of movies. And now I'm going to import this data in Gemstone. This is actually a Gemstone snippet that executes this code within a Gemstone database. So not in Pharo or in GT, in a Gemstone database. And when I execute this, I'm going to get a debugger. So in this case, I have a problem in this code. And now we can see this shows us the execution stack that happened within Gemstone. And in this case, we use a UI that's very similar to the one of the normal debugger in GT. And if we go down, actually, the problem I know it was here because I put a +1. So for example, I could delete it, save. And now if I step over, yeah, this computation now works. Before there was an error. And again, at any time, I could switch, go back to GT. And now I can see how I got to this point, how I got to calling into Gemstone. And in this case, something happened, and now I'm waiting on a promise, and the computation in this case happens within Gemstone. And as one final example, let's debug Python. So here we have a snippet that in this case runs Python code. So it's connected to a Python server that runs in the background. And I'm going to run this code, and I just put a breakpoint in factorial. So now we get a totally different interface. This is a more standard interface where we can see the stack. This is how we got to this point, and here actually I'm in my factorial where I have just a breakpoint every time. So I could step into, I'm again on the stack, I could proceed, and then I get a few more. It's just factorial of 3, and now it's finished. And if I inspect the value, I got 6 back. So these were three examples of domain-specific debugger. So every one of these is a standalone debugger that applies in a certain context. It works, but problem is they are hard to implement. It's not necessarily easy to implement one of these debuggers. You really need a few days maybe and a lot of knowledge about what's going on, about the debugging framework. However, if we go to other tools in GT and Faro, for example, like the object inspector, it's quite easy to add a custom view to an object inspector. It's not that complicated. Here, for example, we're looking at an object that represents a Git repository. We can see, for example, changes, commits, the directory, details, and we have also some actions. And if I want to see how one of these actions is implemented, I can alt-click, and this shows me how this is implemented. So in this case, I can see that I'm in the same class, Git repository, and I have a method that has this annotation GTView. And then this uses an API to create this visualization, more or less. It says, I want to display these items, and it should have 2 columns, more or less. But it's a method in the class of the object that returns the view, like print string. And the same is for actions. Let's go to fetch, for example. If I look at fetch, it's again a method in the class of the action, annotated with GT action, that creates a button with some action when you click it. So it's quite easy to do this. And because it is, if we look at how many of these we have in GT, so now I'm going to look all the methods that have that GT view annotation, pragma. And if we count them, so this is a view that just counts them using an animation for effect. So it will reach 360, more or less. So there are quite a lot of extensions within the IDE for viewing objects. But now let's count how many debuggers are there, how many custom debuggers are in the system. 9. So there is a difference. 3009, it's a bit sad. So the idea is, can we make extending the debugger as easy and as simple as extending the object inspector? Let's see how we could approach doing that. Here I have one example. We are going to create a graphical element, so just a visual element. We're going to set some properties like scale it by something, translate it, rotate it, and they're going to apply transformation on it. We're going to try to inverse it, more or less. And this is going to fail because this operation, if you scale by 0, it's bad. You shouldn't try to do this. But let's try to just debug this. We start first, let's create the element, make sure it is initialized. And now let's step into this operation that applies this transformation. Okay, we have a check, and now we're going to we have a matrix, and now we're going to step into the inverted message. And here, now we have a matrix. So we're looking at the matrix object. I can see some information about it, but it would be really nice to actually see the matrix here. It's a 3x3 matrix, not that big, we should be able to look at it. We could do that by inspecting self, so by inspecting the matrix object. We get a new pane to the right, and now we have this matrix view. But now we have to do this. We have to see what object is interesting. We have to do this operation. Maybe we don't know that this view exists, and we don't even click there. So what we can do is tell the debugger to take this view from here and show it in the debugger, actually. And to do that, it is enough to add another annotation. We can just add GT context view. So the debugger will always look at the self, the current object, and say, do you have any views for debugging? If yes, I can show them in the debugger. So if I save this, and I go back, and I select again the context, I get the matrix view. So we just extended the debugger with one line of code in case we had the view. Otherwise, we would have needed to create it. But this means that every view that we have for an object, if it's interesting in a certain point for debugging, we can just show it in the debugger. We don't have to let the user dive into the right object to see what view is interested for this particular context. Now let's continue. So let's see copy, and let's go in inverse. And now actually this is going to trigger an exception. So I'm going to proceed and see that exception. And in this case, this exception is very specific to this matrix. So more or less, depending on how you decompose a matrix, if the determinant is 0, you cannot invert it. More or less, it's math. And in this case, only when I have this exception would be nice to see the decomposition of the matrix. but only for this exception, not any time I look at the matrix, because the decomposition is not interesting for any operation. And in this case, we actually have it. So this is a view that shows, in this case, this decomposition. And if this is 0, if the inner matrix is more or less like this, then I cannot invert it. It's not a bug. This is how it works. And if we look at the actual implementation, again, I can alt-click on the view and see its implementation. It has a similar annotation, but this is GT context view followed by the exception. So this says only show this view in the debugger in case the debugger has this exception, was open at this exception. So this means you can have an object that defines views on how to be shown when multiple different exceptions are happening. It doesn't have to look the same depending on the actual exception. It can adapt to the exception. And up to here, we can add views. But what about actions? Because for an object, we could also have those actions that are very similar to the view. And for this, we're going to use a Zinc example. And what we are going to do here is just execute a code to Gmail. And hopefully, I set the number of redirects to 3, and hopefully it does more than 3 redirects otherwise. So let's execute, and we get a debugger. So we get this error that says too many redirects happen. Actually 4 happen, that's why I put 3. And now, what I would like to do is retry this with 4 redirects. I want to see if a different number of redirects is working. So we have here a retry action where I could specify the number of redirects. By normally doubles the number of redirects. So now when I'm going to click on this, the debugger will go on the stack, find the Zinc client where the request happens, set a different value, and restart the execution. And how is this implemented? If I click to see the implementation, it's exactly as a normal object action. It's an action in the class, in this case of the exception, because it's a stack action, and it has this GT stack action annotation. So more or less the debugger will look in the exception for any methods that have GT action and use them to create an action in the debugger. And here also passes as a second parameter. This is a debugging context, which gives this code access to the actual debugger. So using this, the action can do whatever it wants with the execution. It can change it, restart it. So if I retry and put, I don't know, let's try 4, it succeeded. So now I can inspect the result. So this is just, doesn't make sense, but like this, I could just do this. And what is interesting, if I do this again, I will still get the error because I just changed the value in that request. I didn't change it at all. And interesting here is that, for example, before, I really wanted to know here what were the URLs that were retried. I've been redirected. And through what URLs have been redirected. And by default in Zinc, there was no way to get that information. But what we did is we did a small extension. We just added, for example, a trail. So we added to this method another parameter that collects the trail of the URLs. And actually, if we have that, we can just show it. So now if we have this exception, we can just show this information, which is quite useful. If this is my case, it's useful. But we can do this before this was not done, before this was not existing, because maybe there was no way to show this information. But the moment we can show things, maybe we want to collect more things, have more more exceptions, complete exceptions, so we can show more information about what is happening in our system. And now that we have this in place, let's look at how we can use it in a few concrete scenarios. So one, of course, is assert equals. So this is normal. I have an assert equals, it fails, and I get a diff in the debugger. So in this case, I'm just comparing two strings. So of course, we can show them using a nice diff, or we can look at the state if you want to manually compare. But now the question is, how is this implemented? Because this is my standard debugger. It's here. And now I have here another kind of debugging interface that is shown for this exception. And if I actually inspect the exception, you will see that we get the same view. Actually, we'll get both of these views are defined in the exception. And now if we look at how they are implemented, by looking at textual diff, so I'm looking at the implementation of this, you will see that it has, in this case, it's a different one, is GT exception view. So this is what we call moldable exceptions. So whenever the debugger is raised as a result of an exception, not only do we extend the standard debugger interface with views and action, but we ask the exception, do we have specific views annotated with GT exception view? And we take those and we use them to create a different debugging interface. So more or less, whenever you have an exception, you can say, don't show the stack by default, show something else, please. That maybe makes more sense. So then having this debugger is nothing special. It's just an exception that defines a view, and we can use this view whenever the exception happens. It's nothing special. It's just a normal extension to the debugger. And let's look at something more complicated. So we have this, a case where we started to use this quite a lot is when we have APIs that users need to use. So before, so the user, so this is an error, an object that we use to test various errors when creating views of an object. And there are many ways in which it can fail. And for example, if we have this limit, so this is when I'm creating a view, and if there should be no view, we have to return more or less a view empty. So this is what we return. You don't return the parameter, you return a view empty. That's what we want users to do because of reasons. But that's how we design our API, more or less. And if the user does this, we're going to throw an exception and tell, hey, something is wrong, and we say, here's the exception, please look and debug it yourself. Before, we are having this, plus a long exception message that was describing to the user, hey, please go and modify your code to return a view empty instead of a view. So, okay, we can also detect it statically, but not in all cases. But now, we could try to do it differently. We could throw a custom exception in this case. So let's rerun this execution. And now we get our standard debugger and a different interface. Just quickly before I go into it, if I inspect the exception, I get the same view. The exception defines this view, and in this case, we use this view within the actual debugger to show a different interface. And this explains a bit what happens. So it says, this flow view created by this method returned a view argument. So it's these arguments that were returned. We can also highlight, it says, please return a view empty instead. Yeah, we tell the user what to do, but then we can also have actions. We can offer the user a fix and say, okay, apply this fix and continue execution. So in this case, this action is a fix-it action that opens the in-place refactoring, and I can see what the fix is going to do. So now I can just accept, this will apply the code, resume execution, and continue. And just what's interesting here is that also this method is no longer on the stack. Because if I go back just here, so here is where the place, you don't have to understand the code, but this is the place where we executed that method. We got back the wrong result. And then here we just checked if it returned the wrong result. So then if this happens, we trigger the exception. So in this case, when we are going to do this, the debugger has to figure out a bit what should I restart, where should I go, and what should I do in order for things to work. And now if we apply, it's fixed. I mean, there were two here. So it rerun the execution, and in this case, because the view is empty, it will not be shown. And this was the actual implementation of the view. So now, for example, you can see it changed this to a view empty. So now I didn't have to know anything about how to fix this, about the framework. The framework detected the error, it thrown an exception, and the exception told me what to do, provided me some details that I could directly action about. And we use this quite a lot with APIs instead of just returning error messages describing what to do. We find that it's much easier to return an exception that defines views and actions that then allows the user to do something or understand better instead of him having to manually figure out what to do. Okay, so until now we talked about the debugger. However, no debugger maybe is better than a debugger. So the debugger is it's a complicated tool. Even with views, it's a tool that allows you more or less to understand the runtime execution. Use a debugger when you want to reason about an execution. And because it's easy, we use it in quite a lot of places. But then the idea is, but also the debugger pops a new window, it jumps at you. So it breaks your context. You're doing something and then says, hey, something happened, and you get something that doesn't fit in your current flow. So the idea is, what we try to also experiment is, would it be possible to take some flows that usually are done within the debugger and not do them in the debugger. Offer a way where you can do them in place without necessarily having to always go to a debugger for those flows. So let's take a simple one of creating a method, for example, and a class. So here I just have a class. I have some code. It wants to create the class my information new, but this doesn't exist in the system, so we can create it. That's nothing special. We can say I want to create this. I need a package, maybe it's isag. Now I have this class created, it's empty, And now I execute this code. So now I have message points to hello, and then action is this object. And in the next snippet, what I have is a method. So this method is not yet implemented, so it's red. Now I could run this code, get a debugger. The debugger will offer to create this method for me. But again, I'm going out of this flow. I'm here, I'm coding, now I'm opening a debugger that takes me somewhere else. In this case, I could say I want to create a method. That's fine. But now often we use the debugger because we need parameters to be bound. We need values for parameters, and usually they don't exist in an editor. But here, if you look above, we have in the initial context, in the snippet, we have the values for the parameters. So actually we can pass them here. So now if I inspect a string, it's the actual value. So now I can continue developing this method here, right in the expanded editor, with all the parameters and self being bound. I don't have to go somewhere else. So for example, I will just initialize label, for example. Let's say label, a string equals a string. I can create the attribute because it doesn't exist. I will save, and now I can actually execute this method because I have all the information that I need. So I'm going to execute, and I get the action that has label set with this value. Normally, this is something that we'll only do in a debugger. Of course, it doesn't work in all cases if you don't have the values exactly like here mapped, but if you do have them, you can just use. And anytime we have a method and we can expand, and we know the values in the context where we are, we can pass them down to the method that we expanded. If we can expand 20 times, we can still pass if we know around the values. So this is one. Another has to do with tests, or we have examples, and that is, okay, I'm having a test, I run it, and the test is going to fail. Normally you get green or you get yellow or red, depending on what happened. And then you open a debugger to see where exactly the failure happened. But do we need to do that all cases? Maybe not. So here I'm going to execute this. I broke this assertion here. So if I execute, we get this. So now in the editor, we can highlight, for example, the place where this happened. Error, assertion, whatever, failed. And then maybe I want to see now what is the actual exception. In this case, we have it here. We could also place it in different, so I want to inspect it. So now we can see that we had a test, it failed here, and it triggered this assertion failure, and this is exactly the same view as before that we have at the level of the exception. So now we can see, okay, it failed here, and this is the reason it failed. This is just an inspector. We are just inspecting. This is an inspection flow. It's not a debugging flow. Now, if I want to go in the debugger and see more, yeah, I will use the debugger. But if this is what I wanted to know, I will not need to do that. Now, if this is expected, I could just fix this. And now my test is green, and there was no debugger involved to see the error, the assertion, what failed, and to fix it. And last but not least, let's look at one more example. And this has to do with, again, debug. So we have tests or examples, and we want to debug them, more or less. We want to not necessarily debug them, we want to execute them and understand what is happening. Let's open a debugger on this test. We have our debugger, and now we can, for example, do some actions. I'm going to step over, step over, step over. And now maybe here I remember, okay, I would have really liked to add another or create another page here. Let's say I would have really, or add a snippet to this page. I would have really wanted to have this page 2, add snippet. And now I'm going to say text snippet. String, doesn't matter. But now, if I save this, all the execution that I previously did will be gone. Maybe it was a web request, maybe it was somehow more, the setup maybe was longer. They will be gone. The debugger can only go sequentially. It goes from up to down. If I want to execute in another order, it will not really work. If I want to change and save, again, I lose everything. I lose the entire context that I had. So if I will save here, now, I have to start executing again from the very beginning. And why? Why is it that always when we like to step to the execution of a test, we have to do it in the debugger? Maybe we don't, all the times. In this case, we have actually a button here which says, okay, I want to take this test or example and extract it to a playground. So in this case, this is in this class. So it says, okay, I'm going to create an instance of this class, and I'm going to take this code and replace self with example. So now I got a playground that contains more or less the same code as the example in this case. And now if I want, I can play differently. Maybe I want to split it here. I can execute this part. Maybe I just want to execute this part. I want to go here. Now I can execute this part. Okay, now maybe I change my mind. I want to re-execute this part. So now I can choose. I can play. I don't have to be in an order that's always from top to bottom. Doesn't matter, it always works, but there is an alternative if that's what we want to do and what we need to do. So flows that were usually done in the debugger may not necessarily all the time have to be done in the debugger. So yeah, that's what I wanted to show you today. And just like inspectors tend to be generic, just show you the state of the object. So debuggers usually, even if we are debugging very different applications, like we saw, parser, Python, gemstone, debugging views, different things. They all look the same. And ideally, that doesn't have to be. If they all look the same, we are the ones that have to extract the information and see what to do. However, if it's easy to extend the debugger, we can be in a different world, one in which the debugger is also moldable and adapts to our context. Yeah, thank you. That's what I wanted to say.
So for the implementation for the debugger for Python, for example, there is a hook into the debugger interface of the Python.
It's debugger adapter protocol. Yeah. You can connect to other language, JavaScript or Python. Okay, break then. Thank you.